2 days back, I think last week, we have gone through the starting of DC motors, in which we have learned whatever the necessaries of the starters, as well as why starter is required for the DC motor starting. All that things we have gone through. Then various types of starters like 3-point starter, 4-point starter with advantage, disadvantage we have learned. So last point of the second unit is a speed control of DC shunt and series motors. Okay, so now for the applications, as per applications, there are various speed ranges which are required. So that means what, variable speed is required, and we have the option by using the DC motors for this such application where we need to control the speed. So now whatever the methods, what is the process to control the DC shunt motors. So first of all, we will see whatever the questionnaires will be asked on this topic. Okay, so see here, question number 7, question number 8. Okay, so question number 7 and 8, that with help of neat diagram explain speed control methods of DC shunt motor, and this question were asked for the 6 marks, whereas explain with neat diagram speed control of DC motor by flux control method and armature control method, this question were asked for the 8 marks. That means what, flux control method will get 4 marks and armature control method will get 8 marks, and this question were asked in November 17. Okay, so according to me, these whatever these 8 9 questions are there listed, 8 1 to 10 questions, these questions are very important. So once we'll finish the unit, you start to write the assignment on these questions. Okay, so it will be very easier to you guys to revise and also to keep remember. Okay, then again here is one question 11, explain different methods of the speed control of DC motor, but it was for the old syllabus where the question were asked for the 10 marks, and this question for the 10 marks. Okay, that numerical we will see later. So you just keep in mind that 2 questions will be asked like all the speed control methods for the DC motor, otherwise they will ask you particularly flux control as well as armature control method. Okay, now we'll go through the speed control of DC motor. So first of all, we have to clear one thing, that what is the parameters, which parameters we need to control. So by using that parameter we can control the our DC motor. So first of all, we know that the speed is directly proportional to the back EMF and inversely proportional to the fluxes, isn't it? But also we know that EB is nothing but what, EB is V minus IRA. Okay, and this K taken for the proportional constant. So only the EB is replaced by the value we, I will write here. We know that for the motor, per motor, EB is equal to V minus IA RA, isn't it? So just replace that EB by V minus IRA RPM. Now one more thing again, if there is a DC shunt motor, then the total resistance is only RA. But if there is a series motor, then our total R will become RA, that is armature resistance plus series resistance, isn't it? Why? Because see, this is the diagram for the shunt motor, and this is the diagram for the series motor. Now you can understand, here is our some resistance which is a RA. Okay, so while calculating while we are doing the calculations or controlling the speed of a DC shunt motor, then you should just consider only armature value, armature resistance value. But in case of the series, here is also RSE. Okay, that is a resistance of field circuit. Here we are not considering that one, but here we need to consider, because these two resistances are in a series, that's why we have to add these two, then we'll get the R is equal to RA plus RAC. Okay, so now see, from that equation you should understood the speed of the motor is importantly or basically depends on the fluxes. Okay, so we can say by varying, by changing the fluxes, we can vary the speed. That's why the motor is known, that method is known as a flux control method. Why this method is known as a flux control? Because in that method we are varying our flux per pole, and due to that our speed will be vary. Okay, then second thing, now suppose we will consider that fluxes are constant. Again, that voltage is a constant. Then what thing we can change? We can change the value of resistance. What we can change? We can change the value of resistance. Okay, so if we'll change the value of resistance, what will happen? By changing the value of resistance, what will happen, we will see in the detail. But this resistance value is nothing but for the armature circuit. That's why we can say that method is known as a armature control method. By varying the value of resistance, we are varying the current, armature current, and once we'll vary armature current, then easily we can vary the speed. This is another one method, that is armature control. Why? Because the resistance value which is present at armature circuit, we are varying that one by using rheostat. Now we'll suppose that IaRa is a constant, that fluxes are a constant, then which parameter will matters with the speed? Then the parameter is voltage. If we vary the voltage, then our speed will also vary. So by that mean, we can say by controlling the voltage of or supply voltage of the motor, we can vary the speed. So that's why this is known as a voltage control method. Any doubt? If you want to write it down, just take it. Write it down on your notebooks. Once you will done, just message me. Somebody just message me in chat box, or somebody just tell me on unmute yourself and tell me. Have you done? हाँ बोला. Okay, have you done?
Yes, sir.
Okay, fine. Now we'll go for the first method, that is a flux control method. Okay, so one by one we will see. So see, here you can see the resistance in diagram. Just you concentrate on the diagram. Okay, so in this diagram you can see the resistance or rheostat which is connected in series with the field winding, right? Now you know that direction of the ISH, IA and IL, the total IL is equal to IA plus ISH. Okay, so now in that case what we have to see, we have to check the speed and armature current characteristics. Okay, so first thing we know that if we will vary the flux, how we will vary the flux? Once we will control the field current, have field current madla jo current ahe, if we manage that current, then at most our fluxes will vary. Okay, so by varying the value of the rheostat, we are increasing the resistance or decreasing the resistance. So once we will increase resistance, then the current will decrease, current will decrease, then fluxes will decrease. Am I, you're clear my point? So first, that fact which varying the fluxes, the motor speed can be changed, and that's why it is known as a flux control method. So here, first statement that you can consider the field rheostat which is connected in a series with the shunt field winding. Okay, you can see in this 5.1 figure. Okay, so now what will the procedure, how it will affect once we vary the resistance by using the rheostat, then it will affect or it will reduce the this current, shunt field current. And due to that, if our shunt field current is decreasing or reducing, that means the fluxes will also what will happen about fluxes? If field current is decreasing, what is the effect on that fluxes? Tell me anybody.
Decrease.
Yeah, it will decrease, and therefore we can only improve our speed of the motor. That means what? If we need to increase the speed or raise the speed of the motor above the normal speed, if there is some kind of normal speed of the motor, and that time if we want to raise the speed above normal speed, then how? See, this is the normal speed and we need to raise the speed up to this point. So at that time what we will do, we will just reduce the resistance, and due to that our current will increase and fluxes will also get increased, and then our speed will get increase. So that means what? That method is permits or allow to increase the speed in the ratio of 3:1. Okay, so ratio of 3:1, which is wider speed range, which tends to produce the instability and poor commutation. What we can say for the instability? Because instability means was, if any motor will run after its normal speed, at that time there may be a vibrations in a motor. डू यू अंडरस्टँड? व्हायब्रेशन्स होतात. मोटर जर एका लिमिटच्या वरती पळायला लागले, then there is a vibrations, or we can say this is a instability. Okay, this is a instability, and due to that this motor having some disadvantage as well as advantage. Okay, so we'll gone through also that advantage and disadvantage. Okay, see, advantage of this motor, that motor is very easy and convenient method, because only we need to add the rheostat in series with the field winding. That is the very easy and convenient method. Also, it is an inexpensive method, since very little power is wasted in shunt field rheostat due to the relatively small value of ISH. Already we know that the value of field current is always very low. So due to that, there may be a very low losses in case of shunt field rheostat which is connected in series with the shunt winding. And also this motor, this method will not have a more that expenses. Okay, so due to that, this method is a very advantageous. Then again, speed control exercised by this method is independent of the load on a machine. See, we are not going to change any armature current. We are just going to change what value? The ISH, and ISH will affect to the fluxes, and once we will reduce the value of ISH, our fluxes will reduce. So that fluxes will reduce will affect on the speed of motor. So that's why we will keep the resistance value low. Due to that, our ISH will increase, which increases fluxes, and due to that, speed of motor will get vary. Okay, these are the three advantages which you need to write in the examination for every control method. Then there may be, if there is advantage, then also disadvantages are there. Now see, if our speed, as I told you, that our motor can achieve the speed above the normal speed, which is very higher as a ratio of 1:3 ratio. So due to that, we cannot reduce our value of RSH below the what we can say, whatever the normal speed can be obtained, that value of resistance cannot be reduced below the shunt field winding resistor. Okay, means what? There is a some certain manufacturing resisting value of the shunt winding, and we cannot reduce that value below the RSH. Okay, so due to that, this is one kind of disadvantage where high speed of the motor beyond the normal speed of motor can achieve. Again, there is a one disadvantage or limitation which can limit to the maximum speed obtainable by this method. Means what? आपण याच्यामध्ये काय करता येतं आपल्याला की whenever we want to achieve a maximum speed which can be obtained by this method, there is a limitation. Why? Because of the instability. And there it is, because if fluxes is too much weakened, that you know that if fluxes are very poor, then we can say there is a poor commutation. Okay, pure commutation. So the first thing we should keep in mind while we are varying the speed of motor. So first thing that we need to limit the maximum speed obtainable by the method, and second thing that it is because the fluxes, if fluxes will get a weakened, then that commutation becomes poorer. Okay, so these are the disadvantage of the what we can say, these are the disadvantage of the flux control method. Okay, so for today we'll just, this is all about the speed control. So we'll just revise whatever the we have learned in previous lectures. So one by one, just tell me. I will ask you questions. Okay, first question, who will answer? I will just stop sharing.